Today we're going to talk about inverse hyperbolic functions. Remember that, recall. If a function is 1-to-1, or if it passes horizontal line test, we say that the function is 1-to-1. In that case, you can find the inverse of that function. Then we can find the inverse of the function. So remember that, for example, from algebra, if f of x is equal to 2x plus 1, and if I ask you to find the inverse of this function, the steps where we are interchanging x and y. Here your y is equal to 2x plus 1. So you're going to interchange x and y. You're going to write down x on the other side, and then you're going to have y instead of x. So x is equal to 2y plus 1. We interchange x and y. Then we isolate our y. So in isolating the y, we're going to add 1 to x on the other side. You get x negative 1 equals to 2 times y, and then divide by 2. You're dividing by 2. Your y becomes x minus 1 divided by 2. Then you're going to say that, hey, f inverse is x minus 1 divided by 2. For some functions, it's super easy to calculate the inverse. Another function that you remember is exponential function and the logarithmic function. Recall that. If y is equal to b to the x, or if f of x is equal to b to the x, you have exponential function. It is 1-to-1. It is a 1-to-1 function. And you can find the inverse of that function, which is logarithmic function. Log with base b of x. Another recall for you. If y is equal to e to the x, or if you take f of x equals to e to the x, of course it's exponential function. Of course it is 1-to-1. It is a 1-to-1 function. So the inverse of this function is ln of x, natural log. So these are the basics of inverse of a function for a linear function, for exponential function. Also, when we introduce trig functions, sine and cosine, another recall for you. If you take y equals to sine of x, or if you write f of x equals to sine of x, this guy is 1-to-1 on interval negative pi over 2 to pi over 2. It is 1-to-1. So we can define the inverse of this function. From pre-calculus, the inverse of this function is defined as arc sine of x, or the inverse is defined as sine with negative exponent 1x. With the same logic, we define the inverse of cosine, the inverse of tangent, and so on. Remember the graph of these types of functions, all right? If you have sine function, for example, the graph of the sine, as you remember, from negative pi over 2 to pi over 2 behaves like this. This is the graph of sine of x. The inverse is mirror image with respect to the line y equals to x. So you could define the inverse sine using the following graph. Inverse sine of x, or arc sine. We did the same thing for cosine, inverse cosine, tangent, inverse tangent, and so on. Now that we introduce a new function, hyperbolic function, we are interested in finding the inverse of hyperbolic functions. Hyperbolic inverse. So when you write y equals to arc hyperbolic sine of x, or when you write y equals to hyperbolic inverse of x, it means that x is equal to hyperbolic sine of y. That's the meaning of that. If you want to graph hyperbolic sine, well, remember the behavior of hyperbolic sine, and then you can use it to graph the inverse of it. So the behavior of hyperbolic sine, as you remember, was like this. On one interval, we can define its inverse and the graph, which behaves like this. So this guy is representing the inverse hyperbolic, or hyperbolic inverse of x, and this guy down here is just hyperbolic sine. Now I want to show you that since hyperbolic sine is defined as e to the x minus e to the power minus x divided by 2, I'm going to use that and find the inverse using ln. Take a look. You are using previous definitions. Since hyperbolic sine of x is defined as, or in general, let me use k to avoid any confusion, or u to avoid any confusion, hyperbolic sine of u to be e to power u minus e to power minus u divided by u, and it is containing exponential function. So we expect the inverse of hyperbolic sine of u has some ln in it. Why is that? Again, remember that when you have your exponential function e to the x, this is the graph of e to the x. The inverse of e to the x is ln. This is the inverse of e to the x. So let us try to investigate, see what's happening here. I want to show you that. I want to prove that the inverse hyperbolic sine of x is equal to ln of x plus square root of x squared plus 1. I want to prove this for you. And I'm going to use the definition of inverse function. Very good. So let us begin, everybody. Let y be equals to inverse hyperbolic sine of x. It means that x is equal to hyperbolic sine of y. But remember the definition of hyperbolic sine of u in general. X on the left-hand side is equal to e to power y minus e to power minus y divided by 2. What is my goal? My goal is to solve for the value here and isolate my y. Our goal is to isolate y because I want to show that this y is equal to ln of x plus square root of x squared plus 1. So let us try to isolate y by using algebra. By algebra. Okay, so take a look. What happened here? If you multiply 2 and x, e to power y minus e to power minus y is equal to 2x. Bring 2x to the other side, we get e to y minus 2x minus e to power negative y equal to 0. Take common denominator. How? Since e to power y minus 2x minus 1 over e to power y is equal to 0, taking common denominator between them, which is e to power y, gives you e to power 2y minus 2x e to power y minus 1 equal to 0. Set the numerator equal to 0. So you get e to power 2y minus 2x e to power y minus 1 equal to 0. Can I solve this equation? Is it possible to solve it? Somehow try to write it in the form of a quadratic equation? Recall that from algebra, everybody. K squared, or let me write it down as quadratic to avoid any confusion with this K and the whole thing. Remember that from algebra, if you have a u squared plus bu plus c equal to 0, you could use quadratic formula. U is equal to negative b plus minus square root of b squared minus 4ac divided by 2a. But what is my u here? I don't see any u. Well, I can define u to be e to power y. So define u to be e to power y. So u squared is e to power y times e to power y, which becomes e to power 2y. So this equation becomes u squared minus 2xu minus 1 equal to 0. Following quadratic formula, u is equal to negative b. But what is my b? b is equal to negative 2x. So u becomes negative b, which is 2x plus minus square root of b squared minus 4ac. What is b squared? B squared is 4x squared minus 4ac, which becomes plus 4, divided by 2a or 2. Okay, I'm getting a little bit of hope. My u, which is e to power y, is equal to 2x plus minus, if I factor out 4x squared plus 1 divided by 2, my e to power y is equal to 2x plus minus 2 times square root of x squared plus 1 divided by 2. So e to power y can be written as, if you factor out 2x plus minus square root of x squared plus 1 divided by 2. So I can cancel out 2 and 2. Since e to power y is positive, we only take the positive sign. So let's go back here. E to power y is x plus square root of x squared plus 1. But remember the definition of ln. E to power y is equal to a quantity, so y becomes ln of x plus square root of x squared plus 1. Again, remember that if e to power u is equal to k, u is ln of k. This is the definition of ln and u. So since e to power y is equal to a quantity on the right-hand side, y becomes ln of x plus square root of x squared plus 1. So what we just showed, so we just proved that hyperbolic sine inverse of x is equal to ln of x plus square root of x squared plus 1 using pure algebra, everyone. Let me just separate these. So you see this is plus 1.